It is the oldest question we have ever asked. On a quiet night, under a sky full of stars, every human who has ever lived has wondered the same thing. Are we alone? Tonight, we are going to take that question seriously and follow the science as far as it will take us. Let us start with the numbers because the numbers are staggering. Our galaxy, the Milky Way, contains up to 400 billion stars. And we now know that almost every one of them has planets. For most of history, we did not know if a single other planet existed beyond our solar system. Then, in the last 30 years, everything changed. We began to find them, thousands of them, worlds orbiting other suns. We call them exoplanets. They come in every imaginable variety. Scorching gas giants hugging their stars, worlds of molten rock, planets where it might rain glass sideways. The galaxy is far stranger and far more crowded than we ever dreamed. Sometimes they come in bundles. Around a small red star called TRAPPIST-1, astronomers found not one but 7 Earth-sized planets, and several of them sit in the zone where liquid water could exist. A single star with a whole family of possible Earths. But we are not just looking for any planet. We are looking for a very particular kind. A world in the habitable zone. The narrow band around a star that is not too hot and not too cold, where water can stay liquid on the surface. Water, as far as we know, is the one thing every living creature needs. So we look for worlds where oceans could exist, and astonishingly, we have found them. Rocky planets, roughly the size of Earth, sitting right in that life-friendly zone. One of them orbits the very next star over. Proxima b, circling the closest star to our Sun, sits in its habitable zone. The nearest possibly habitable world beyond our own is, in cosmic terms, just next door. In fact, our best estimates now suggest that our galaxy alone could contain billions of Earth-sized planets in the habitable zones of their stars. Billions of potential Earths in our galaxy alone. How do we even find these worlds trillions of kilometers away? Mostly, we watch for a tiny wink. When a planet passes in front of its star, it blocks a sliver of light. From that faint, repeating dip, we can weigh the planet, measure it, and even read its air. And remember, the Milky Way is just one galaxy among 2 trillion. When you multiply it all out, the number of potentially habitable worlds in the universe is so vast that it feels almost impossible for us to be the only ones. And the raw ingredients for life appear to be everywhere. We have found complex organic molecules, the chemical building blocks of living things, riding on comets, buried in meteorites, and drifting in the clouds between the stars. The universe seems primed to cook up life. And you do not even need to leave our own solar system to find promising places. Because life may not need a warm, sunlit surface at all. It may only need a hidden ocean. This is Europa, a moon of Jupiter. Beneath its cracked shell of ice lies a global ocean of liquid water, possibly containing twice as much water as all of Earth's oceans combined. And where there is water and heat, there may be life. Saturn's moon, Enceladus, does something even more incredible. It sprays its hidden ocean directly into space through giant geysers at its south pole. We have literally flown a spacecraft through the spray and tasted the ingredients for life. Then there is Titan, a moon of Saturn, with rivers and lakes on its surface. Not of water, but of liquid methane. If life can arise there, in that frigid alien chemistry, then life may be able to begin in ways we have not even imagined. And we should not forget our own backyard. Mars was once a warm world of rivers, lakes, and maybe seas. If life ever took hold there, its fossils, or even dormant survivors, could still be waiting beneath the red dust, a few minutes' flight from where you are sitting. So we have billions of Earths and oceans hiding on moons right next door. In 1961, an astronomer named Frank Drake tried to turn all of this into a single equation to estimate how many alien civilizations we might be able to talk to. The Drake equation multiplies it all together. The number of stars, the fraction with planets, the fraction that could host life, the chance that life becomes intelligent, and depending on your assumptions, it suggests the galaxy could be teeming with civilizations, and life, once it begins, is astonishingly stubborn. Here on Earth, we have found it thriving in boiling acid, in solid rock, and in the crushing dark of the deepest oceans. Tiny creatures called tardigrades can even survive the raw vacuum of space itself, which leads us to a terrifying contradiction. If the universe is so vast, so old, and so full of Earth-like worlds, then the galaxy should be crowded with alien civilizations. Some should be millions of years more advanced than us. So where are they? This is the great puzzle, first framed by the physicist Enrico Fermi. The numbers scream that we should not be alone. And yet, we look out at the cosmos and we hear nothing but silence. This is the Fermi paradox. A civilization far older than ours might not be hiding at all. It might be building. Some scientists imagine structures called Dyson spheres, vast swarms of panels wrapped around an entire star, capturing every drop of its energy. If they exist, we might spot one by its strange artificial glow. The most advanced of them may have moved beyond biology entirely, becoming machines that could think for millions of years and cross the galaxy in ships that never tire. If that is what is out there, we may be looking for the wrong kind of life altogether. So why the silence? There are many possible answers, and every one of them is unsettling. Perhaps the birth of life is far rarer than we think, an accident that almost never happens. Perhaps we truly are one of the first. Or perhaps there is a great filter, some barrier that almost no civilization survives. Maybe intelligent life tends to destroy itself through war or ruin before it ever reaches the stars. A chilling thought when you look at our own history. And so we listen. For over 60 years, radio telescopes have swept the skies, searching for a signal, any signal, that could not be natural. In 1977, for 72 seconds, we thought we heard one. A blast of radio energy so strong it was simply named the wow signal. We never heard it again. Or maybe they are out there, but the distances are simply too vast and the signals too faint for us to have heard them yet. Maybe we have only been listening for a single century in a galaxy that is billions of years old. Or, most humbling of all, maybe they are talking, but not in any language or on any channel that a young species like us could yet recognize. We may be like children, listening for smoke signals while the universe speaks in ways we cannot imagine. There is an even stranger idea, the zoo hypothesis. What if they already know we are here and are simply watching, quietly, deliberately, leaving us alone, the way we might observe animals in a wildlife preserve, waiting until we are ready? Right now, we have only one confirmed example of life anywhere in the universe. It is here. It is us. Every living thing we have ever known lives on this single, fragile, blue world. So, are we alone? The honest answer is, we do not know yet, but we are the first generation with the tools to actually find out. Right now, telescopes are sniffing the air of distant worlds, searching for the fingerprints of life. What they are hunting for is called the biosignature, a gas that should not be there. Oxygen. Methane. Chemicals that, on Earth, are only produced in large amounts by living things. Find them together in an alien sky, and it becomes very hard to explain without life. One day, perhaps in your lifetime, we may find it. A single strange molecule in the atmosphere of a faraway planet, and everything changes forever. Either answer, that we are alone or that we are not, is equally staggering. Keep looking up and get spaced out.